Assalamualaikum warahmatullahi wabarakatuh. Good day, ladies and gentlemen. My name is Aulia Fikri Hidayat. I am from the Department of Pharmacy, Faculty of Mathematics and Natural Sciences, Universitas Islam Bandung. Today, on behalf of my research team, I would like to deliver a presentation about exploring the interaction of pyrrolizidine alkaloids in honey with SARS-CoV-2 main protease via in silico approach. This presentation will be delivered as part of the Science and Technology Research Symposium Bandung Annual International Conference 2022. Okay, we will start about the COVID-19 virus. So the SARS-CoV-2 virus is characterized by its enveloped positively strained RNA with approximately 30 kilobase genome and approximately 306 amino acids long main protease, which divides the polypeptides to several sites. And they generates multiple functional viral non-structural proteins, or NSPs. So the NSP itself are responsible for the survival and the replication of the virus. That is the reason why, to overcome the defense mechanism of the virus, and his enzymatic inhibitory toward main protease have been extensively investigated to explore and to discover potential therapies for COVID-19. One of the potential compounds are Pyrrolizidine alkaloids, which found in honey. So the pyrrolizidine is a quite distinct derivative of alkaloids that mostly found in honey, which produced by the Apis mellifera bee. The pyrrolizidine alkaloids were demonstrated as having several beneficial properties such as antibacterial, antifungal, anti-inflammatory, as well as antiviral. So to elucidate our comprehension toward the potential of this type of alkaloids as inhibitor against SARS-CoV-2 main protease, we conducted computational simulation, which is based on the molecular docking. So there were two main steps in our simulation. First one is preparation, and the second one is the main simulation itself. For the preparation, we prepare the main protease of SARS-CoV-2 main protease, which were acquired from the protein data bank, and the pyrrolizidine alkaloids were also downloaded from the same site. We employ 10 pyrrolizidine alkaloids, which are intermediate, licopsamine, jacobin, retrosin, heliotrin, senecyphilin, senecionin, ecimidin, sancurkin, and lasiocarbin. And then the modeling and geometry optimization were carried out using gauss view. After the preparation, we would continue to the main simulation. So the main simulation was the molecular docking simulations of the 10 pyrrolizidine alkaloids, and we explore their affinities and their interactions toward the SARS-CoV-2 main protease as the receptor. The first result will be in the structural conformation, which determined by the total energy of the compounds of the pyrrolizidine alkaloids. This result showed that all of the compounds were negative value in total energy, and it showed that all of them indicating a quite good conformation stability of the molecules, and a quite a stable conformation, which showed by the negative values of the total energy. Okay, after that, the next result would be the docking validation. So the docking method was validated through evaluation of several parameters, and the RMSD value of 1.82 angstroms were found. This is indicating a valid result, which is the requirements for the validity of the result is the RMSD should be less than 2 angstrom. And the next result will be the binding free energy and the inhibition constant. And then we also we compared to the result from the natural ligand. The overall negative values of binding free energy illustrate the affinity of the compounds toward the receptor. So it is revealed that the alkaloids in honey, this pyrrolizidine alkaloids in honey, possess binding affinities against SARS-CoV-2 main protease. The next result will be the visualization of the complexes, which indicated the evaluation of the compound receptor interaction. It is observed that all the pyrrolizidine alkaloids showed similar conformation to that of the natural ligand of the binding site of SARS-CoV-2 main protease. And then for the last result, we calculated the number of interaction of each compound toward the SARS-CoV-2 main protease as the receptor. It is found that all of the compounds were interacted with the receptor. However, the greatest number of interactions was shown in retrosin with 11 interactions, which consisted of 7 hydrogen bondings and 4 hydrophobic interactions. Nonetheless, overall strong and stable affinity of pyrrolizidine alkaloids were resulted due to the hydrogen bondings and the hydrophobic interactions. Okay, so the conclusion, the interaction of pyrrolizidine alkaloids found in honey towards SARS-CoV-2 main protease as the receptor have been investigated using molecular docking simulation. Results found that sancorkin and cynosiphyllin have the closest binding affinities compared to the natural ligand. In addition, the entire compounds were able to form interactions with the receptor as results of hydrogen bonding and hydrophobic interactions. So this demonstrates that pyrrolizidine alkaloids found in honey are quite potential to be developed as SARS-CoV-2 main protease inhibitor, or as the SARS-CoV-2 therapy itself. Okay, thank you. That is all for my presentation. Wassalamualaikum warahmatullahi wabarakatuh.